Hey everyone, this is Dr. Nak. We're going to go over section 3.5, relations and functions. So let's first go with the definition. A relation is any set of ordered pairs x comma y. All the x values in the ordered pairs make up the domain, this thing called the domain. All the y values in the ordered pairs make up this thing called the range. Okay, so let's take an example. For the relation 1, 1, 2, 3, 3, 7, and 4, 3, find the domain and the range. So all the domain values are nothing but the x values. So let me just write down the domain. So this is going to be a set. So which one are the x values? 1, 2, 3, and a 4. So the domain is going to be 1, 2, and then 3 and 4. Now the range is nothing but the y values in the relation. So here our y values are 1, 3, 7, and 3. Notice that you have 2 3s, but in this case just pick one of the 3. So what I'm trying to say is the range is 1, 3, and a 7. That's it. I know that you still want to write another 3, right? But that's already been taken care of. So do not repeat those values. So this is our answer. Alright, let's take a look at example 2. Use the graph of the relation to list the ordered pairs of the relation, find the domain of the relation, and find the range of the relation. Alright, so let's first list the ordered pairs of the relation. So this is our x-axis, that's our y-axis. Okay, so let me just change the color here. Okay, so let's first go with this guy right here. So this is nothing but the origin, which will be 0, 0. Okay, so now let's look at this guy. So our x value in this case is going to be 0. And our y value is 1, 2, 3, 4, 4. Okay, so now let's look at this one right here. So our x value is, let me count, 1, 2, 3, 4, 5, 6. All right, and then the y value is 2. And then this one over here, our x value is 2. And then our y value is -3. Okay, we got 2 more to go. So let's take a look at this one. So that will be x is 1, 2, 3, 4, 5, 6, -6. And our y value is 3. And the last point here, our x value is -3. And the y value is -1. So what we just did was we just listed ordered pairs of the relation. Now let's go with the domain and a range. So the domain, remember, domain is just a set of all x values in that relation. So here what we're going to get is -6, -3, 0, and you have another 0, but we don't repeat that. And here you're going to have a 2, and then 6. And let's go with the range. Range is nothing but the y values. So here you're going to have 3, -1, 4, 0, -3, and a 2. And this is our answer. Now let's talk about this thing called a function. So the definition of a function is a relation that assigns to each element in the domain exactly one element in the range. So this is telling you that for every x, there better be exactly one corresponding y value. Let's do some examples. Example 3, determine whether the relation is a function. So let's do a couple of problems so you can see the difference between which relation becomes a function and which doesn't. So let's first look at A. We are given 1, 2, 3, 4, 5, 6, and then 5, 7. So let me just draw this picture. This is called a mapping picture. So this is going to be our domain. And then this is going to be the range. Okay, so domains are, remember, they're all the x values. So we have 1, and then 3, and then 5. Okay, now let's jot down all the values for the range. Those are the y values. So you're going to have 2, 4, and then 6, and a 7. Okay, now if I map this relation, when x is 1, y is 2. So when x is 1, this guy has exactly one y value, which is 2. Now 3, when x is 3, y is 4. Okay, so in this case, for every x, meaning just for 3, this guy only has exactly one y value, which is 4. Now let's go with 5. The third ordered pair is when x is 5, y is 6. All right, now the last one, it's telling you that when x is 5, it's going to go to 7. Do you see what's wrong right here with the 5? Notice that in order to be a function, for every element in the domain better have exactly one y value. So 5 is the x value, but look at it. When x is 5, we get two outputs for the y value, which is 6 and a 7. So that fails this relation to be a function. So let me just write it out. So therefore, since I'll just write everything out. Since 5 goes to 6 and 7, this relation is not a function. Let's take a look at part B. So we're given this relation 1, 2, 3, 4, 6, 5, and 7, 5. Okay, so let's do the same thing. So I'm going to do the mapping here. So domain, and this is going to be our range. So the domain values are 1, 3, and then 6 and a 7. Let me just write it as domain. This is range. The range values are the y values. So here you're going to have 2, 4, and then 5 and a 5. So let's just keep just one of the 5. Okay, now I'm going to map this relation. So this is telling you that when x is 1, y is 2. All right, so does 1 have exactly one y value? Yes. Now when x is 3, y is 4. All right, so for every x, which is when x is 3, that guy has exactly one y value, which is 4. Looking good. Okay, next one is when x is 6, y is 5. And then when x is 7, our y is 5. All right, so think about it a little bit. So does every element in the domain, does it have exactly one y value? I believe that it does. So in this case, this relation is going to be a function. So let me just write it out. So this relation is a function because for every x, there is exactly one y value. Do you see the difference between part A and part B? For part A, when x is 5, it's going to go to two different y values. So that's not going to become a function. Whereas part B, notice that each element in the domain has exactly one y value. And that's why part B is going to become a function. Now let's play a different game. So for example 4, determine whether the equation is a function. The easiest way to determine whether the given equation is a function or not, first solve for y. Alright, so let's look at part A. 2x plus y equals 6. Okay, so let's first solve for y. How do I solve for y? Is just subtract 2x from both sides. Then here I'm going to get y equals negative 2x plus 6, or you can just write it as 6 minus 2x. It's exactly the same thing. Now don't forget the definition of a function. In order to be a function, for each element in x better give you an exactly one y value. So if I plug this, let me make a xy chart here. So let me just plug it in like maybe 0, 1, 2 or something. Now when x is 0, let me just box this equation. When x is 0, then y is going to be 6. So when x is 0, there's only one y value, which is 6. Now when x is 1, this is going to become 4. When x is 2, this is going to become 2. So notice that no matter what x values that's going to plug it in, you're going to get exactly one y value. So therefore, this equation is a function. So I'm just going to write it. Func means function. All right, now let's take a look at something like this. Suppose we're given y equals x squared plus 2. Okay, so this has already been solved for y. So let me just make a xy chart. You can plug it in any value for x, but I usually go 0, 1, 2 because those are really cute numbers. So when x is 0, y is 2. When x is 1, we're going to have 1 squared, which is 1 plus 2, which is 3. When x is 2, 2 squared gives 4. 4 plus 2 is 6. So if we keep going, do you see that no matter what x value that you're going to plug it in, you're going to get exactly one y value. So again, this equation defines a function. So I'm just going to write it as this is a function. All right, now let's compare it with part C. So now we're going to go with x plus y squared equals to 2. Okay, now solving for y here, what would you do first? Yeah, subtract x from both sides. So here what we're going to get is y squared equals negative x plus 2 or 2 minus x. It doesn't matter. It's exactly the same thing, but I'm just going to write it like this. All right, now let's take a look. Notice that if I solve for y, you're going to have a plus or minus the square root of negative x plus 2. Do you see that? That was one of the properties that we should have learned in elementary algebra. But in case you forget, when you take the square root of y squared, you're going to have a positive side and then also the negative side. So do you see what's wrong with this picture? Because look, if I plugged it in x and a y, let me just make the same chart. I'm going to go 0, 1, 2. Okay, so let me just box this. Now, when x is 0, our radicand is going to become 2, but y value is going to be plus or minus the square root of 2. Do you see that for each x, no matter what, you're going to get two different y values? So in this case, this equation is not going to become a function. So let me write it. So I'm going to say not a function. Alright, now let's talk about the function notation. For the function y equals, now that is read as f of x. F is the name of the function, x is the domain value, but we call the x value the argument of f, and then f of x is the range value y corresponding to x. And one more thing I want to mention is this. F of x, this does not mean that it's f times x, so be careful right there. Also, sometimes your textbook will say this, x is called the independent variable. And corresponding y value is called the dependent variable. All right, so let's do some examples. Let's take a look at part A. Given f of x to be 2x plus 3, find f of 4, f of 0, and f of a plus h. So let's first go with f of 4. Or we say that f evaluated at x equals to 4. So basically all you have to do is this. Notice what the heck just happened. In place of x, I'm going to replace that x with 4. So here what we're going to get is 2 times 4 and then plus 3. So which is 8 plus 3, which will be 11. So this is basically telling you that when x is 4, corresponding y value is going to be 11. So if you want to write this in terms of a relation, meaning that as an ordered pair, this is exactly the same thing as 4, 11. All right, but anyways, let's go with f of 0. So all you have to do is, in place of x, replace that x with a 0. So this is 2 times 0 plus 3, which is just 3. So again, this is telling you when x is 0, corresponding y value is 3. So if you want to put this in terms of an ordered pair, this means that you're going to have 0, 3. All right, now let's go with f of a plus h. Do not panic. We're just going to do the same exact thing as when we're evaluating f of 4 and f of 0. So pretend that a plus h is just one quantity. So what we need to do is, in place of x, you need to replace that x with the whole quantity a plus h. So this is going to equal to 2 times a plus h and then plus 3. Did you catch that okay? All I'm doing is replacing this x right here with the whole quantity a plus h. So if I simplify that, distributing the 2, then we're going to have 2a plus 2h and then plus 3. Since this doesn't have any like terms, this is going to be our answer. Let's do another one. G of x equals negative x squared plus 1. Find g of negative 2 and g of a plus h. So let's first go with g of negative 2. All right, now all we're doing is replacing our x with just negative 2. So here, I need to drop down the first negative sign. Now our x is negative 2, but you're going to have to square that, and then plus 1. So this is same thing as negative. Now negative 2 whole quantity squared is positive 4. So now you're going to have a negative 4 right there now. And then plus 1, which is negative 3. So let me see. This negative is here and then also here. Now let's look at g of a plus h. Again, a plus h is one quantity. So wherever you see your x, you're going to replace that with the whole quantity a plus h. So here what we're going to get is minus a plus h squared and then plus 1. Okay, now simplifying this, be careful. A plus h whole quantity squared means that you need to multiply a plus h twice. So here you're going to get negative a plus h times another a plus h, and then drop down that plus 1. All right, let's keep simplifying this. So the next step, what we need to do is we're going to have to multiply out a plus h times another a plus h. But be careful, there's a minus sign in the front of it. So I'm going to have minus bracket, then we FOIL. So first term is going to be a squared. Why am I writing that in yellow? So here you're going to have a squared. And next one is going to be plus a times h. Next one is going to be h times a, which is same thing as a times h. And the last one is going to be plus h squared. And then drop down the plus 1. So now this is going to become negative a squared plus, if I combine this, you're going to have 2ah plus h squared and then plus 1. Now lastly, distribute that negative sign. You're going to get negative a squared minus 2ah and then minus h squared, then finally plus 1. So that's going to be our answer. All right, let's do another one. H of x equals 5 over x. Find h of 1, h of 0, and h of a plus h. All right, so let's first go with h of 1. So what we're doing is we're replacing our x with 1. So here what we should get is 5 over 1. Always simplify all the way. So our answer is going to be 5. Now let's go with h of 0. Do the same thing. We're going to have a 5 over 0. All right, so what is this? Does that mean this is undefined or is it 0? This will be undefined because remember, you can never divide anything by a 0. So in this case, I'm just going to write it as undefined. Now let's go with h of a plus h. Okay, so again, I'm going to be replacing the whole quantity a plus h in place of x. So here you're going to have to go 5 over a plus h. But what is the restriction on that? Well, you cannot have 0 on the bottom. So what we need to do is, provided that a plus h denominator does not go to 0. But anyways, I'm just going to box this. And there you go. How you guys doing up to here? Maybe we should do another one? Let's do another one. All right, now next one, f of t equals 2 times the absolute value of t minus 5 plus 4. Find f of negative 4. So instead of the independent variable being x, we're going to have a t instead. But procedure is exactly the same. So in place of t, what we need to do is replace that with negative 4. So here we're going to have f of negative 4 equals 2 times negative 4 minus 5 in absolute and then plus 4, which is same thing as 2 times absolute of negative 9 plus 4. So this is going to be 2 times 9 plus 4, which is 18 plus 4. So what is that? 22. And that's our answer. All right. Why in the heck not? Let's just do another one. A, B, C, D, E, E, E. All right. So let's go with maybe g of t. I'm going to make something up. T squared minus 1 all over t plus 2. All right. Now let's go with find g of, what should we do here? Maybe g of negative 2. All right. So let's do this. So here what we're going to get is g of negative 2 equals, so in place of t, we're going to have to replace that t with the negative 2. So here you're going to have negative 2 squared minus 1 all over negative 2 plus 2. Oh no. All right, but anyway, so this is going to become negative 2 whole quantity squared is 4 minus 1 dividing by 0. And here we're going to have 3 over 0. So our answer is undefined. All right, so anyways, I will just stop here. I hope you guys are kind of getting the hang of it. If you have any questions, please let me know. And once again, great job.